graph this next example. So just like before, the first thing I'm going to do is I'm going to graph y is equal to, r is equal to sine theta. Remember, this axis is r and this axis is theta. And as we know, sine starts at 0. Say here's 1 and here's 2, here's -1, here's -2. It starts at 0, it goes up to 1, goes back down to 0, goes down to -1, back to 2, back to 0. Those are the y values, or the r values in this case. So the graph looks something like this. This 2 in front here, that's vertical stretch. Vertical stretch. Okay. So that means when I go to actually graph this for realsies, I'm going to take each of those y values, multiply it by 2. 2 times 1 is 2. 0 times 2 is 0. -1 times 2 is -2. And 0 times 2 is 0. So when you go to graph this, this looks like this. Like this. I'm going to go back. I'm going to delete my sine graph because I don't care about that guy. The one I really care about is r equal to 2 sine theta. Now I go to graph each of these guys. So when theta is equal to 0, I'm facing in this direction. How far out do I go? I go out a distance 0. Next, when theta is equal to pi over 2, I'm facing this direction. I go out a distance of 2. So going at a distance of 2, r equal to 1 is here, r equal to 2 is right there. Okay. So what's happening is I start off with a radius of 0, and as I rotate 90 degrees, so as I go from 0 to pi over 2, my radius is increasing from 0 to 2. So that means as you turn, this guy kind of expands outwards, and it reaches 2 like this. Okay. That's this part of the graph right there. Okay. So now I'm going to delete the part that this is theta equal to 0 part. And I'm going to delete this part right. Oh, shoot. Delete that part. Oh, shoot. This part right there. And then now I want to graph the next part. So the next part goes from pi over 2 to pi. That's this part right here. And when theta is equal to pi, I'm facing this direction. That's pi. Okay. So what's happening there? My radius starts off at 2, but as I keep turning, as theta goes from pi over 2 down to pi, what's happening is my radius gets smaller and smaller and eventually drops back to 0. So that's kind of captured by the fact that we're starting at radius 2. As my angle theta rotates, my r gets closer and closer and closer and closer to 0. So I end up back here. So that's this part, and this is the direction that I'm going in. Does that make sense? So that's going from pi over 2 to pi. So now I can delete that. Oh, shoot. Delete this. And then I can delete that part. And now let's worry about the next leg. The next leg goes from pi to 3 pi over 2. So 3 pi over 2 means you're facing downwards like this. That's 3 pi over 2. And what's happening there, in this case, my radius is going behind me. My radius is going behind me, but this time I'm going from 0 out to -2. So -2 means when I'm facing the 3 pi over 2 direction, I actually go behind myself to a -2, right? So that's really tracing out that part of the curve again. Okay. So I hope you guys can see that this is kind of becoming the same thing as the example 6. So the final part we have goes from 3 pi over 2 to 2 pi. That's this leg. So if I go out 2 pi, I'm facing this direction. This is 2 pi. And as theta goes from 3 pi over 2 to 2 pi, what's happening? Again, my radius is negative. It's going behind me. And I trace out the left side of that circle again, like this. So just like before, we're going to get a double circle. So we get a double circle. Okay. So if you looked at our cosine example earlier, this was a double circle of radius 1. And that was sort of centered along the x-axis. So I almost think of it as a horizontal circle. And this is more like a vertical circle. It's a double circle, really. Okay. So I can actually get rid of these highlighting marks. And if you were to work it out, you could get the Cartesian equations similar to what we did over here. You can multiply both sides by r. This time you're going to have a something that looks like this. This is going to be x squared minus y minus 1 squared is equal to 1. So this is a circle of radius 1 centered at 0, 1. All right, cool.